second example tells us that the probability that a randomly chosen member of a reading group is left-handed is 0.15. We're given that a random sample of 20 members of the group is taken. For part A, we're asked to suggest a suitable model for the random variable x, the number of members in the sample who are left-handed. Now, because our random variable x can take two values, we're either left-handed or right-handed, we're thinking maybe the binomial distribution here, because remembering that the binomial distribution, we want to have two possible outcomes. We're also told that there are a fixed number of trials, because we're told that it's taken a sample of 20, and we're told that there is a fixed probability of success. So all we need to do is assume that the number of members in the sample is independent, and then we've ticked off those 4 bullet points for being able to use the binomial distribution. So just writing that up, I would say that the random variable can take two values, left-handed or right-handed. So that there, we've satisfied the property that in order for x to have a binomial distribution, there needs to be two possible outcomes. So that's the second bullet point on that input slide. We're then going to write there are a fixed number of trials, which is 20, and a fixed probability of success, which is 0.15. So here we've ticked off the property that there's a fixed number of trials n and there's a fixed probability of success p. So that's the first and third bullet point from that input slide. The last bullet point says the trials must be independent of one another. So assuming each member in the sample is independent, which it should be. The idea of one person being left-handed and the other person being left-handed, those events are independent to one another. They don't depend on each other. A suitable model is, and we wouldn't just say the binomial distribution, we would actually write down what the binomial distribution of x would be. So we'd say x has the binomial distribution where n, the number of trials, is 20, so the index is 20, and then the probability of success is 0.15, which is our parameter. For part B, I, it's asked to find the probability that the number of members in the sample are left-handed is 7. So probability that x equals 7. So we're going to do n, which is 20, choose r, which is 7. Our probability of success to the power of r, which is 7. And then 1 minus our probability of success to the power of n subtract r, so 20 subtract 7. So again, in our calculators, we're going to do 20, choose, I just turned it off, 20, choose 7, which is 7, 7, 520, multiplied by 0.15 to the power of 7. I'm just going to keep that written as 0.15 to the power of 7. 1 subtract 0.15, that is 0.85. We're doing that to the power of 13. Just going to write that as 0.85 to the power of 13, and then going to type all of this into my calculator. So I've got 0.85 to the power of 13 multiplied by 0.15 to the power of 7 multiplied by 77520. So that's equal to 0.0160 to 3 significant figures. For part II, we're asked to find the probability that there are fewer than 2 members that are left-handed. So the probability that x is less than 2. So if x is less than 2, remember x can take a value from 0 to n, so 0 to 20. This must be the probability that x equals 0 plus the probability that x equals 1. If we were to also add the probability that x equals 2, we would have x is less than or equal to 2, which is not what we want here. Now the probability that x is equal to 0, we've got 20 choose 0 multiplied by 0.15 to the power of 0, 0.85 to the power of 20 subtract 0, which is 20, and we're going to add 20 choose 1, 0.15 to the power of 1, 0.85 to the power of 20 subtract 1, which is 19. Now, similar to our previous example, this is going to equal 1, that's going to equal 1, so we've just got 0.85 to the power of 20 for the first probability, and then we're going to add 20 choose 1, which is going to be 20, so 20 choose 1 is 20 multiplied by 0.15 multiplied by 0.85 to the power of 19. I'm going to type this into my calculator. So 0.85 to the power of 20, oops, not 200, plus 20 times 0.15 times 0.85 to the power of 19. And my answer is 0.16 to 3 significant figures.